Hey guys, so in this video I'm going to talk about air from PSM. So let's start. First about the measurement of temperature. So we have two thermometer, Kata thermometer and globe thermometer. As you can see the Kata thermometer, we have this thin tube, and globe thermometer have very thick and round globe. This will be of red color, the Kata thermometer, and the globe thermometer will be of black color. So this is the basic difference. This is of red color, this is of black color. This will be thin and this will be round and thick. Also this globe thermometer is known as bulb thermometer. Now what does this two actually measures? So this Kata thermometer is going to measure this cooling power of air and also low air velocity, and bulb thermometer is going to measure radiant heat and effective temperature. So this two thing of both of this we have to remember, that Kata is going to measure the cooling power of air and low air velocity, while this bulb or globe thermometer is going to measure the radiant heat, and that's why it can measure the effective temperature of environment. Now this is a sling synchrometer. It has wet bulb thermometer and dry bulb thermometer. Wet bulb thermometer can measure the environmental heat. So this is radiant heat here in bulb, and in wet bulb it is environmental heat. And these two together, dry bulb thermometer and wet bulb thermometer, is going to measure the humidity. So synchrometer is used to measure the humidity level in environment. Now this two about the velocity of air. So this anemometer is going to measure, velocity, not velocity but about the wind. So anemometer is going to measure the velocity of wind, and this wind vane is going to measure the direction of wind. So this is velocity and this is direction. As you can see here, it is a arrow pointing towards the direction in which wind is flowing. So and in this it is going to measure the velocity. So two about this wind, this was about the humidity synchrometer, and this two about the temperatures. Now about the pressure. So for that barometer, as you can see here, atmospheric pressure it is going to measure air pressure, also called as barograph. So this was about air pressure, wind direction and velocity, humidity and temperature of environment. Now about the air quality. So first we have to learn about the components that we use to measure the air quality index. So air quality index, it has PM 2.5 and PM 10. This is a size actually, 2.5 and 10 micrometer, I think. So this two kind of particle, and this 2.5 PM particle is the most dangerous. this is why less than 5 pm is dangerous size. Why? We know that if it is more than like 10 around, then it is not actually deposited in the lung. But if it is very less than size, then it is going to taken up by macrophage, but this size is going to actually deposit in the lungs. That's why it is a most dangerous size. Apart from this, there is going to be some gas like carbon monoxide and NO2, then NH3, then O3 mean ozone, and SO2 plus lead. So these are the components that we take up to measure the air quality index. Now some particular things about some components. So SO2 is the the best air pollution indicator, the chemical. But if we talk about the biological indicator, then it is lichens, and it is inversely proportional. So air pollution is inversely proportional to the level of lichens in the air, and it is a biological indicator. So the more will be lichens, the less will be air pollution. Now this ozone. So ozone is a secondary pollutant. Why? Because we know that we have a ozone layer actually, but if the ozone is present on the ground level, means it is a ground level ozone, then it is a secondary pollutant. And so this is most dangerous one. Ozone is secondary pollutant. SO2 is overall the best indicator for air pollution. And now about the global warming. So or greenhouse effect. H2O, water vapor, is the water vapor has the maximum effect of greenhouse, then carbon dioxide, then second number is of carbon dioxide. Now there is two things we have to two indexes. One is soiling index and another is GREET. So soiling index is due to smoke and the GREET index is due to dust. Now about this air quality index. So we know that 0 to 50 is good. Yes, good. 51 to 100 is actually satisfactory. Then this 101 to 200 is moderate. So this 2, and this one is 201 to 300 is poor, and this is divided into two parts, very poor and severe. So you can remember that 0 to 100 is divided into two parts. 0 to 50 is good. 51 to 100 is satisfactory. Not good, but yeah, we can live with that. So satisfactory. After that, this grading will start from above 100. 100 to 200 it is moderate. Then 200 to 300 it is poor. Then 300 to 400 it is very poor, and 400 to 500 it is severe. Remember, there is no very severe. The severe is the last one, and it is from 400 to 500, and above that, below that, poor and very poor one. And this color coding is like this only. So 0 to 50 good means green color, 51 to 100 is satisfactory means yellow color, and this moderate is of red color means 100 to 200. Then 200 to 300 is poor, and this 300 to 500 is of maroon color. Okay, so this was about air. Now we are going to discuss light. So in light we have to remember some units. So first, brightness. Brightness of source, also known as luminous intensity, is candela. Then the second one we have to remember is on the surface. So total light on surface, this is also known as illuminance. So don't confuse these two, luminous and illuminance. Luminous intensity is actually brightness and illuminance is light that is on the surface. So we know that the lux soap we use on the surface, so lux and candela. Now the third one we have to remember is rate of light emission, is also known as flux. It is of lumen. So these three units. First, remember that we are seeing a light source. So the intensity means brightness, how actually this bright is. So it is called as luminous intensity. It is measured in the candela. Now the second thing, you can remember the rate at which light is going, it is coming from it. So light emission, it is known as flux, and the unit is lumen. And the third one, how much actually the light is on the surface, so illuminance, it is by lux. So this one I think you can remember easily, lux, surface and illuminance. But the difficult part is this one, this lumen, rate of light emission, also known as flux. So remember that flux and lux don't together. Flux is lumen. Okay. Now about the sound. So we know that it is in decibel. We generally talk in the range of like